Hello students, welcome to Academy, the place for mathematics and science. Dear students, in yesterday's class we were discussing the chapter polynomials, right? Now let's go for continuing this, and do remember this is second period of this chapter. Yesterday we got the basic information about this chapter. Once we shall recall them, all these. The first one was, it is definition of polynomial. Yes, recall the definition, or you can just tell with me. An algebraic expression involving the variable whose power is non-negative integer is called a polynomial, right? Then what is its general form or standard form of polynomial? Yeah, it can be written as polynomial in x, that is p of x, is equal to a0 x raised to the power 0, a1 x raised to the power 1, a2 x raised to the power 2, and so on, plus an x raised to the power n. Now here x is variable. a0, a1, a2 up to an, they are all real numbers, right? Then what do you call the highest power of the variable? Yes, it is degree of the polynomial. The highest power of the variable involved in the polynomial is called its degree. And we have also come to know that based on degree, we can go for classifying the polynomials into different types. Then if it is so, what do you call a polynomial of degree 1? Yes, you are right. It is linear polynomial. Then what is its general form? It is ax plus b, where a is not equal to 0, right? Then what do you call the polynomial of degree 2? It is called quadratic polynomial. General form, recall that, ax square plus bx plus c, where a is not equal to 0. Third one, yes, what it is? You are right, it is cubic polynomial. Then how do you define this? It can be defined as a polynomial of degree 3. It is, and the standard form is ax raised to the power 3 plus bx square plus cx plus d, where a is not equal to 0. Then what do you call a polynomial of degree 4? Yes, it is biquadratic polynomial. What about its standard form? Yes, you can go for telling it is ax raised to the power 4 plus bx raised to the power 3 plus cx square plus dx plus e, where a is not equal to 0. You all know that in this chapter we are focusing up to cubic polynomial, right? Then one more important polynomial is there whose degree is 0. Could you tell what it is? You are right, it is constant polynomial. A polynomial of degree 0 is called constant polynomial. Then what is its standard form? Just we go for writing a, where a is any real number. Is it not? Then after this we learned one more important concept. When you go for taking any polynomial, in that variable will be there. And the value of the variable which makes the value of the polynomial is called, could you tell what it is? Yes, it is called 0 of the polynomial. 0 of the polynomial. The value of the variable which makes the value of polynomial as 0 is called 0 of the polynomial. Now, and after this, we were discussing about the geometrical meaning of 0 of the polynomial, right? Geometrical meaning of zeros of polynomial. Zeros of polynomial. Then in that we discussed up to quadratic polynomial. I hope that you might have remembered. Then in case of linear polynomial, could you tell what is the nature of graph of linear polynomial? Of course, you are right, it is a straight line. In case of linear polynomial, the graph will intersect the x-axis at a point, and we call this point as 0 of the polynomial. It will intersect the x-axis at only one point. Hence, we can also say that linear polynomial has only one zero. Then, quadratic polynomial. What is the nature of graph of quadratic polynomial? It's very important. Yes, it is parabola, and we draw like this. See, this is parabola. Even you may get the parabola in the shape of inverted U as well, right? But there is a condition for these two. Under what condition we get upward U? It is in the standard form if A is greater than 0, which is the coefficient of x square. If A is greater than 0, we get upward parabola. Then if A is less than 0, we get inverted parabola. And when you draw the graph of quadratic polynomial, whatever the parabola we get, this will intersect the x-axis at two distinct points. Hence, we say that quadratic polynomial has two zeros, even at most two zeros, because even there are some chances where we get only one zero, where we won't get any zeros with respect to quadratic polynomial. And we have already come to know the conditions for all these. Here two zeros are there, and the two zeros are different. Then what is the condition for that? In quadratic polynomial, if the value of b square minus 4ac is greater than 0, we get two zeros. Now, look here. Again, I go for drawing this graph of quadratic polynomial. Observe this one. Parabola meets x-axis at only one point. Then it has only one zero, right? It means, actually it has two zeros, but both the zeros are same. Then what is the condition for this? It is b square minus 4ac is equal to 0. If this condition is satisfied, the graph will meet the x-axis at only one point. Next, and the third condition was also learned. You might have remembered that. Look here. Here, the parabola does not meet or intersect x-axis at any point, right? It means the quadratic polynomial has no zeros. Then what is the condition for this? It is b square minus 4ac is less than 0. Clear? Less than 0 means negative. If the value of b square minus 4ac is negative, then we won't get any zero of the quadratic polynomial. So this much was discussed in the last class. Now, dear students, let's go for continuing this chapter. Now, let's move on to know about the geometrical meaning of zeros of cubic polynomial. Dear students, we are very familiar with cubic polynomial. What is its degree? It is 3, right? A polynomial of degree 3 is called cubic polynomial. What about its general form? It is ax raised to the power 3 or ax cube plus bx square plus cx plus d, where a is not equal to 0. Then what is the nature of the graph? Look here, we have some chances. Observe, this is a graph of cubic polynomial. Even it may come like this also. Next, and we have one more chance. Look here. What is saying? In all these cases, whether we have got straight line, parabola or curved line. Yes, it is curved line. All are curved line. Hence, nature of graph is curved line. The number of zeros, we have already come to know that in case of linear polynomial, 1 degree, 1 0. Quadratic, 2 degree 2, 2 zeros. Cubic, degree 3, hence it must have at most 3 zeros, right? Number of zeros, all right, 3. Then here also we have to write, that is the graph of cubic polynomial intersect the x-axis at how many points? At most 3 points. Got it? At most 3 points means even it may intersect x-axis at 2 points only or at 1 point only. Hence we can come to know there are 3 conditions. Let's go for taking these conditions. Case 1, case 2. This is case 2 and is case 3. I'll take a simple example. Suppose x cube is there. Could you tell how many zeros it has? When to find out zeros of x cube, you will equate this to 0. You can write x cube as x into x into x, which is equal to 0. Now, you can equate each of these to 0. X equal to 0, next, second x equal to 0, third x equal to 0. How many zeros? 3 zeros are there, but all the zeros are same only. Hence, we get only 1 point. Clear? Next, there is only 1 0. Even I'll go for taking x minus 1 whole cube. Then could you tell how many zeros? X minus, to find out the x minus 1 whole cube, again you can equate this to 0, and this can be written as x minus 1 into x minus 2 into x minus 1 into x minus 1 into x minus 1, which is equal to 0, and equate first x minus 1 equal to 0 and second x minus 1 equal to 0, third one x minus 1 equal to 0, x equal to 1, x equal to 1, x equal to 1. So all the zeros are formed at only 1 point. Actually 3 zeros are there, all the 3 are equal, but here the graph will intersect the x-axis at only 1 point. Hence we say that it is just 1 0. Clear? Here right, 1 0. Then second case, observe this one. Here the graph has intersected the x-axis at 2 points. Then we can say that it has 2 zeros. Then usually you may go for taking like this, x cube minus x square. How do you find out the zeros? Observe here, x cube minus x square, that is equal to 0. Then when you take out x square as common factor, you will get x minus 1 equal to 0. Now you can equate x square to 0 and x minus 1 to 0. Here x equal to 1. What about here? X equal to 0 and x equal to 0. As here there are 2 zeros which are same and 1 0 is different. Hence we show only 1 point here and another point here. Clear? So the graph has intersected x-axis at 2 points, hence it has 2 0. It means in out of total 3 zeros, 2 zeros are same, 1 will be different. Next, I go for taking 1 more. Here you can notice that the graph has intersected x-axis at how many points? Count 1, 2, 3. 3 points. Then can we write there are 3 zeros? Yes. If you go for taking an example, x minus 1 into x minus 2 into x minus 3. Find out the zeros of this polynomial. I have not taken the polynomial directly. Instead, its factorization is taken only for the sake of understanding. On equating it to 0, see, x minus 1 can be equated to 0, x minus 2 can be equated to 0, and x minus 3 can also be equated to 0. What is the value of x? 1. Minus x minus 2, here 2. X minus 3 equal to 0, x equal to 3. There are 3 different zeros. Hence we can say that it has intersected the x-axis at 3 different points. Clear? Huh? Okay, now pause the video and copy from there to here. Next, dear students, and one more important polynomial, that is a polynomial of degree 0 is called constant polynomial. Then how many zeros of a constant polynomial has? Yes, what do you say? We know that zeros of constant polynomial cannot be defined, right? Okay, now let's move on to some of the worked examples. These questions, these are given in the textbook. I have taken the same. Go through this. First one. Look at the graphs given below. These are the graphs. Total 6 graphs are there. Each is the graph of a polynomial y equal to p of x. Then, where p of x is a polynomial, for each of the graph, find the number of zeros of p of x. Dear students, we have already learned how to find out the number of zeros by using the graph. You know that the graph of the given polynomial will intersect the x-axis at some points. Then the number of points on the x-axis it intersects, that will be equal to number of zeros. Based on that, let's go for answering one by one. You are going to find out the number of zeros of first polynomial. Okay, can you tell how many? Only one. Why? Because the graph has intersected x-axis at only one point. Clear? Here I write. The graph of p of x has intersected the x-axis at one point only. Therefore, the number of zeros is 1. Therefore, number of zeros is 1. Clear? Next, for first one only I have written dated. From second onwards, I will go for writing it directly. How many zeros? It has, the second graph has 2 zeros. Second polynomial has 2 zeros because its graph has intersected the x-axis at 2 distinct points. So, 2 zeros. Observe the graph of third polynomial. Here, the graph has intersected the x-axis at 3 distinct points. Hence, we can say that it has 3 zeros. Here I am right. The number of zeros, it is 3 zeros. Next, fourth one. Here, the graph of the given polynomial has intersected x-axis at only one point. Therefore, we can say that it is only 1 zero. 1 0. Next, whereas fifth one, the graph of the polynomial has met the x-axis at only one point. Therefore, number of zeros will be 1. 1 0. Sixth one, in this case, the graph of the given polynomial has intersected the x-axis at 4 distinct points. Hence, number of zeros is 4. Clear? Then just by observing only, you go for telling the type of the polynomial. Not given, but only for the sake of information. This one, you can come to know that it is cubic. This is quadratic because it is parabola. This is cubic, curved line. This is straight line. What do you say? Linear. This is parabola, nothing but quadratic polynomial. This is biquadratic polynomial. Clear? Yeah. Take scale and pencil and go for drawing all the graphs neatly. No need to go for using the graph sheet. In your notebook only, it should be continued. Yeah. Please copy from there to here. Dear students, now we will move on to exercise questions. In this exercise 2.1, only one question has been given. In that 6 graphs are given like previous one. Let's go through the given statement. The graphs of y equal to p of x are given below. Find the number of zeros in each case. Again same. First one, could you tell how many zeros it has? In first case, you can come to know that the graph of the given polynomial is parallel to x-axis. It means it has not intersected the x-axis at any point. Hence, we can say that the number of zeros is 0. Next, second one. The graph has intersected the x-axis at only one point. Therefore, it has 1 0. Third one. The graph has intersected the x-axis at 3 distinct points. We can say that it has 3 zeros. Fourth one. Parabola has intersected the x-axis at 2 distinct points. We can say that the number of zeros is 2. Fifth one. The graph of the given polynomial has intersected the x-axis at 4 distinct points. Hence the number of zeros is 4. Next, sixth one. Observe here. This graph, here it has intersected the x-axis at one point here. It meets the x-axis at this point as well as this point. Total how many points are there? 3 points. Hence we can say that the number of zeros is 3. Clear up? Dear students, again you have to write from there to here. Use scale and pencil to draw these 6 graphs again and write neatly. Then after this we will move on to the new concept, which is very important in the examination point of view. Yes, go for copying it quickly. Dear students, we have learned how to find out zeros of a polynomial. That is, when polynomial is given, we know how to find out its zero. For example, 2x plus 3 is a polynomial. You are going to find out its zero. How do you write? 2x plus 3, it should be equated to 0. Then you will go for solving x. 2x is equal to, you will transfer 3 to the right hand side, it becomes minus 3. X equal to minus 3 by 2. So, minus 3 by 2 is called zero of this polynomial, 2x plus 3. Polynomial is given, we have found out zeros. 0. Then, is it possible for us to form a polynomial when 0 is given? Certainly. Just we go for in the reversing order. Look here, x equal to, minus 3 by 2 is 0 of a polynomial. We do not know what is that polynomial. You can find out like this. 0 is given, you are going to form a polynomial. Let x equal to minus 3 by 2. Cross multiply. 2x equal to minus 3. Transfer minus 3 to the left hand side. 2x minus 3 becomes plus 3 is equal to 0. We want polynomial. It is an equation. I go for taking only LHS part. So the polynomial is 2x plus 3. Clear? So there are two concepts. One is when polynomial is given, we learned how to find out 0. When 0 is given, now we are going to learn how to form a polynomial. And this is with respect to only linear polynomial. What about with respect to quadratic and cubic? There is general form for forming a polynomial when zeros are given. Now let me go for teaching you that. You just go through this heading. Here it is. To form a polynomial when zeros are given, I'll go through one by one. The very first one is, what is that? Forming a linear polynomial. Forming a linear polynomial. Dear students, you know that how many zeros does a linear polynomial have? How many? Only 1 0. So let us assume that 0 as alpha. Dear students, in the chapter real numbers only, when I was explaining the concept, I introduced some of the Greek letters like alpha, beta, gamma, delta, theta, right? So many are there, but you must know up to here. Alpha, beta, gamma, delta. Alpha, A-L-P-H-A. Beta, B-E-T-A. Gamma, G-A-M-M-A. Delta, D-E-L-T-A. And even method of writing also. Once I will show you that. Alpha. See how simple it is. Like a proportional. Beta. Observe. Beta in reverse order. Usually we write B like this and don't go for writing in this way. It should be in this order. Beta. Gamma. Then delta. Clear? Okay. Now forming a linear polynomial. So to form a polynomial, linear polynomial, we need 0. I am going to assume that let alpha be a 0 of linear polynomial. Then I can take this as x. X equal to alpha. Then x minus alpha is equal to 0. X on transferring alpha to the left hand side, it becomes minus. X minus alpha equal to 0. We want polynomial. P of x equal to x minus alpha. Hope that you have understood. Now we will move on to second one. What is second one? It is quadratic polynomial. Here I will write. Second one is forming a quadratic polynomial. Forming a quadratic polynomial. We all know that how many zeros does a quadratic polynomial have? How many are there? There are 2 zeros. I am going to assume those zeros as alpha and beta. Let alpha and beta be the zeros of quadratic polynomial. Then I can go for taking x equal to alpha and x equal to beta. 2 zeros. Transfer x to the left hand, alpha to the left hand side. X minus alpha equal to 0. And beta to the left hand side. X minus beta equal to 0. Both are equated to 0. Hence we can write x minus alpha into x minus beta equal to 0. Clear? Next, go for multiplying x with both the terms. X into x, x square. X into minus beta x. Minus alpha minus alpha should be multiplied with both. Minus alpha into x, minus alpha x. Minus into minus, plus. Alpha into beta, alpha beta equal to 0. Now, x square, look here, you can take out x as common factor, right? Minus x as common factor, you will get beta plus alpha. Hope that you have understood. Plus alpha beta equal to 0. So it is an equation, but I want polynomial. Hence I go for taking only the LHS part. X square minus x of beta plus alpha can be written as minus of alpha plus beta into x. Only for the sake of order I have written so. Next, plus alpha beta. So this is the general form of forming a quadratic polynomial when its zeros are given, alpha and beta. Clear? Next, one more is there. What is that? Third one is forming a cubic polynomial. Here I will write. Third one, forming a cubic polynomial. Then you all know that how many zeros it has. The degree of the cubic polynomial is 3. Therefore, it has 3 zeros. Hence, you can go for assuming that alpha, beta and gamma be the zeros of cubic polynomial. Clear? Now we can go for writing this as x equal to alpha, x equal to beta, and x equal to gamma. These can be rewritten as x minus alpha equal to 0, x minus beta equal to 0, and x minus gamma equal to 0. All are equated to 0. Hence, we can go for writing this as x minus alpha into x minus beta into x minus gamma equal to 0. Hope that you have understood. Dear students, you all know that this is in the form of an identity. LHS part is in the form of an identity. Can you tell what is that? Yes, you are right. It is. Here only I will go for writing x plus a into x plus b into x plus c. How do you write this? This can be written as, last year only you had learnt about identities, x plus a into x plus b into x plus c. It is x cube plus of a plus b plus c into x, right, plus ab plus bc plus ca into, sorry, this is x square, this is x plus abc. Do you all remember? Based on this, let me go for explaining this. Here, I'll write, okay, x minus a, x minus b, x minus c form, right? In place of a, minus alpha, b minus beta, c minus gamma. I am going to substitute that. This can be written as x cube as it is, then plus alpha plus beta, sorry, a plus b plus c. A is minus alpha, b is minus beta, c is minus gamma into x square plus then alpha beta. Here AB is there, in place of a minus alpha, place of a minus beta. So minus alpha into minus beta plus BC minus beta into minus gamma plus CA minus gamma into minus alpha plus ABC minus alpha into minus beta into minus gamma. Clear? Next, here I'll write x cube. Here you can take out minus as common factor. On taking minus as common factor, you will get alpha plus beta plus gamma into x square. Next, plus, observe this one. Here, minus alpha into minus beta. Minus into minus plus alpha into beta, alpha, beta. Here also, beta into gamma, beta, gamma. Gamma into alpha, gamma, alpha. Got it? Into x. Then, here also, just minus alpha into minus beta into minus gamma is there. Multiply into minus sign. Minus into minus, plus. Plus into minus, minus. Minus into plus, minus. So, there are odd number of minus sign is there, hence you will get minus. Then alpha into beta into gamma. Got it? Which is equal to 0. Now, observe this. Here, we have got the equation, but we want polynomial. I am going to write the polynomial. Polynomial is p of x is equal to x cube minus of alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. Clear? Now I am going to highlight this with the box. So this is general form to form a cubic polynomial when 3 zeros are known. Understood? Observe. Here, this is the linear polynomial when one zero is given. And quadratic polynomial, it has 2 zeros. When 2 zeros are given, you can go for forming the polynomial by using this statement. Then when 3 zeros are given, you can form a cubic polynomial by using this statement. Clear? Please do remember. Okay. First one, p of x equal to x minus alpha. Then, where alpha is 0. P of x equal to x square minus alpha minus of alpha plus beta into x plus alpha beta. Then, for cubic polynomial, p of x equal to x cube minus of alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. Understood? So all three are very important. I am going to put star mark for them. Here just only one zero is there, which is alpha. Here 2 zeros are there, and observe here we have got the special property alpha plus beta and alpha into beta. What do you call alpha and beta? Zeros. Alpha plus beta, sum of zeros. Alpha into beta, product of zeros. Clear? Then I am going to put double star mark for this. Next, here cubic polynomial. In this alpha, beta and gamma, these are 3 zeros, right? Then what do you call alpha plus beta plus gamma? Sum of zeros, right? Come to this one. Alpha into beta into gamma. What it is? Product of zeros. What do you say about alpha beta plus beta gamma plus gamma alpha? Yeah. The sum of 2 zeros. See, the sum of the product of 2 zeros taken together. We have taken two zeros, alpha beta, beta gamma, gamma alpha. Their product is taken and those products are added. Hence we can say it as the sum of the product of 2 zeros together. Clear? Yes. Actually these steps are not given in your textbook, only for the sake of understanding and to learn the concept in detail. So I have written this. Please go for copying and don't forget to learn whatever I have written in the box for linear polynomial, quadratic polynomial and cubic polynomial. For cubic polynomial I put just 1 star. Yes, pause the video, copy from there to here. Dear students, just we have come to know how to form a polynomial when its zeros are given. Right? Maybe the linear polynomial, quadratic or cubic polynomial. But in your syllabus, they have focused more on quadratic polynomial only. Anyhow, I am going to give you a bit information regarding other two. Hence, I have taken first one like this. Observe worked examples in that first one. Find a linear polynomial when its zero is given like this. First one, 11. Actually, you no need to go for using that general form. Directly it can be written. Here on right. Look here. I'll take the 0. 1 0 is given, that is 11. Let x equal to 11. Then transfer 11 to the left hand side. X minus 11 equal to 0. Then LHS part is polynomial. So therefore, P of x is equal to x minus 11. This is the linear polynomial. So observe this, its degree is 1. Next, second one, it is also the same way. Let x equal to 3 by 2. Go for cross multiply. 2x is equal to 3. Transfer to the left hand side. 2x minus 3 equal to 0. Therefore, the required polynomial is, that is P of x is equal to 2x minus 3. I have taken only the polynomial in x. Next, third one. minus 4, it is a 0. Using this 0, we have to form a linear polynomial. Let here x equal to minus 4. Take this to the left hand side. On transferring, it becomes plus 4. It is equal to 0. LHS part is polynomial. Therefore, p of x equal to x plus 4. Understood? Next, fourth one. Minus 2 root 3, 2 into root 3 is a 0 of a linear polynomial. Let's go for forming a linear polynomial. Here I'll write let x equal to minus 2 into root 3. Then transfer minus 2 into root 3 to the left hand side plus 2 into root 3. It is equal to 0. What is the polynomial? P of x is equal to x plus 2 into root 3. Hope that you have understood. Next, now let's move on to second question. This is very important. I have taken all these from your NCERT text. They are also important in the examination point of view. Let's go through the given question. Find a quadratic polynomial. The sum and product of whose zeros are respectively. Look here. They have given sum and product. In case of quadratic polynomial, we know that general form when zeros are given. What is that? P of x is equal to x square minus of alpha plus beta into x plus alpha beta. Right? Here, what do you call alpha plus beta? It is sum. Sum of two zeros. Alpha into beta, product of two zeros. Here what has been given? Observe. Sum and product are respectively. Look here, first one, 4 and 1. What do you call 4? 4 is not a 0. It is sum of two zeros. That is alpha plus beta. 1 is product of two zeros. I will go for writing. Observe here. Let alpha plus beta equal to 4 and alpha into beta equal to 1. We know that quadratic polynomial is given by, we write like this, p of x equal to x square minus of alpha plus beta into x plus alpha beta. Now I am just going to substitute. It is equal to x square minus of, what is alpha plus beta? It is 4. 4 into x plus alpha into beta 1. So p of x equal to x square minus 4x plus 1. This is the required polynomial. Clear? So here I'll write. It is the required polynomial. Which polynomial? Quadratic polynomial. Hope that you have understood. Now I'll go for taking second one. Minus 3 and 2. Second one. Minus 3 and 2. Then here, what do you call minus 3? Minus 3. As per the question, it is the sum. 2, it is the product. So here, let's go for assuming. We know that quadratic polynomial has two zeros and we have taken those two zeros as alpha and beta. They have given sum and product. Hence, we can write alpha plus beta equal to minus 3 and alpha into beta equal to plus. Then quadratic polynomial is given by, that is when zeros are given. It is p of x is equal to x square minus of alpha plus beta into x plus alpha beta. It is equal to x square minus, what is alpha plus beta? Minus 3 is there. Hence, I'll write it inside the bracket. Minus sign is there. Into x plus alpha beta plus 2. We can write it directly. This is equal to x square minus into minus plus 3x plus 2. Understood? Even you can write the conclusion in another way as, therefore, the quadratic polynomial is x square plus 3x plus 2. I'll write that also. Conclusion, therefore, the required quadratic polynomial is, what it is? X square plus 3x plus 2. You may write the conclusion either like this or like that. Hope that you have understood. The second main is very important. So please go for copying from there to here. Now, with respect to second main, just we shall go for taking 3 more examples. Look here. They are given sum and product. We are forming quadratic polynomial. In the first 2, there were only integers, right? Now I have taken rationals as well. Observe it. Here, third one, 1 by 4. What does 1 by 4 indicate? It is sum. And minus 1, that is product. You know that alpha and beta are the zeros. Hence, I take that alpha plus beta equal to 1 by 4. And minus 1 is product. Alpha into beta is minus 1. And we all know that quadratic polynomial is given by, it is p of x is equal to, now we can write x square minus of alpha plus beta into x plus alpha beta. Clear? Let's go for taking substitution. X square minus, what is alpha plus beta? It is 1 by 4 into x plus alpha into beta, minus 1 is there. So I am writing it inside the bracket. It is equal to, now x square, we know that 1 into x, 1x, minus is there. So it can be written as 1x by 4 or x by 4. Plus into minus, minus. Plus into minus, minus, it is 1. Now observe here, denominator 4 is there. So to write the terms in the numerator, I am going to multiply the denominator with all the terms. Here only one term is there in the denominator, 4. I am multiplying that. If 2 terms are there, here one term, here another term, then you have to take LCM of all the 3 denominators. Then you go for multiplying with each term. Clear? Here what is in the denominator? 4. Hence I am going to multiply 4 with all the 3 terms. Here, then when you multiply 4 here, it becomes 4x square. When you multiply 4 to the second term, 4 into x by 4, 4 get cancelled, x will remain. Clear? So just x only. Minus, multiply 4 with 1, it is 4. So in bracket you can write 4 is multiplied, and we can write p of x equal to 4x square minus x minus 4. Therefore, we can write if the quadratic polynomial is, or the required quadratic polynomial is 4x square minus x minus 4. Even sometime we will go for taking this in k into, usually when the zeros are in fraction or sum and product are in fraction, even you may take k here, k into this much, k into remaining, k into this much, k into this much. Then here we write k equal to 4. Okay. So to avoid the confusion, I have written it directly, but only you just give the reason because 4 is multiplied. Next, I'll go for taking fourth one. Here root 2 and 1 by 3. Here an irrational and rational number. Both are there. Alright. Could you tell what does root 2 indicate? It is alpha plus beta. That is sum of zeros. Then 1 by 3. It is product of zeros. Alpha into beta equal to 1 by 3. Next. The quadratic polynomial is given by, or else you can write, we know that P of x equal to this one. Here I'll write P of x is equal to x square minus of alpha plus beta into x plus alpha beta. It is equal to x square minus of, what is alpha plus beta? It is root 2 into x plus alpha into beta, it is 1 by 3. Now observe the denominator, 3 is there. What should be done? Here we have to multiply 3 with all the terms. We cannot multiply 3 with LHS and RHS. Why? Because it is a polynomial. Clear? So here I'll write 3x square minus 3 into root 2x plus, multiply 3 here, get cancelled, 1. So P of x is equal to this much. So in bracket you can write what has been multiplied. Therefore, because 3 is multiplied, or 3 is a constant. Now, here I'll write, therefore, the required quadratic polynomial is 3x square minus 3 into root 2x plus 1. Got it? Yes. Next, we'll move on to fifth one. Here we have two fractions or two rational numbers but opposite in sign. Then, what does minus 1 by 4 indicate? It is sum of zeros. That is alpha plus beta. Or even you can write like this also. Let alpha and beta be the zeros. Then alpha plus beta equal to minus 1 by 4. And alpha into beta equal to 1 by 4. Next. Quadratic polynomial is given by, or else, as I said, we know that, what do you know? It is polynomial, quadratic polynomial P of x. It is equal to x square minus of alpha plus beta into x plus alpha beta. See that I am showing you the different ways of writing. But all steps will be considered for the marks. Never mind. Now this is equal to x square minus, what is alpha plus beta? Minus 1 by 4 plus alpha into beta, it is 1 by 4. It is equal to x square minus into minus plus 1 into x by 4 plus 1 by 4. Observe the denominator. Here is 4, here is 4. What is the LCM of 4 and 4? 4 only. Hence multiply 4 with all the terms. Then we can write 4 x square. When you multiply 4 here, only x will remain, and when you multiply 4 here, 4 get cancelled, 1 will remain. In bracket I'll write, because 4 is multiplied, then it is P of x. Conclusion. Therefore, the required quadratic polynomial is 4x square plus x plus 1. I've been telling you repeatedly, this concept is very important. You need to practice this. Yes. Pause the video and copy from there to here. Dear students, now we are moving to the very interesting part of this chapter. Do you know what it is? Now, you only will be able to tell that. Just I am going to give you the example. We are very familiar with the different types of polynomial based on their degree, right? What do you call a polynomial of degree 1? It is called linear polynomial. What is its standard form? It is ax plus b, where a is not equal to 0, right? Then here, what do you call a? A is called the coefficient of x, right? And b is called, that is coefficient of x raised to the power 0. Hence, a and b are coefficients. Then what do you call x? It is a variable. Then what it is also called? After finding the value of x, yes, it is called 0 of the polynomial. You know that how to find out the 0. Ax plus b, it should be equated to 0. Let us solve x. Ax equal to, transfer b to the right hand side, minus b. Then x equal to minus b by a. Clear? Now you tell, what do you call minus b by a? It is 0 of this polynomial, right? Then x is nothing but 0 of polynomial, given polynomial. And observe each term in this fraction. Here minus, then what do you call b with respect to this? B is a constant, nothing but the coefficient of x raised to the power 0. It is also called constant term. Then it is divided by, what do you call a? A with respect to x, it is coefficient of x, right? Understood? So here is the 0 and these are the coefficients. Got it? Then what do you say? What do you say with respect to these two? You can make a heading. There is a relationship between what? 0 and coefficient, right? Even when you go for taking the quadratic polynomial ax square plus bx plus c, where a is not equal to 0, what are its zeros? We know that quadratic polynomial has two zeros, they are alpha and beta. So there must be here, if there is a relationship between the 0 and the coefficient, here also there must be relationship between zeros and the coefficients of quadratic polynomial. Understood? Yes. Now we can write the heading. What? Relationship between zeros and coefficients of a polynomial. Just we have come to know the relationship between zeros and coefficient of linear polynomial, x equal to minus b by a. What about with respect to quadratic polynomial? That's why I told you this part is very interesting. Let's go for discussing this part in tomorrow's class. Okay. So dear students, before concluding today's class, I remind you again, whatever we have covered, work out these without fail and don't keep anything pending. And with this, let us stop the class. Thank you.